So Jim, I certainly, when I first started cutting my teeth in smart grid security, you know, the Certicom came out in a discussion I heard about with Itron, and I know that's always been one big partnership, but could you speak about perhaps that and some other areas that you've been actively deploying in the smart grid?
Sure, I guess, so Itron is our most well-known partner in the smart grid, and we're deploying in their OpenWay product. So we have a product that was jointly designed with Itron for secure key management of their smart meters. We're working with other companies as well, and so we offer a range of products from full solutions to cryptographic libraries and design services. On the Zigbee side, I think that's actually something that we've done quite well in. We have about 15 libraries for different microprocessors, resource-constrained devices from 8-bit, 16, 32-bit. Those 15 libraries have been distributed to about 150 different companies around the world. About 45 of those companies have actually built certified products and basically come to Certicom. We know they come to Certicom for digital certificates, and we've issued 14 million digital certificates for Zigbee 1.x products. So in terms of actual deployments, while that's not quite smart grid, it's really CAN, that is fairly significant. And I think there's probably about 13 million of those 14 million Zigbee certificates are deployed. Maybe 13.5 million of those are deployed in smart meters from almost every major meter vendor. I think there's one meter vendor that's still yet to deploy any Zigbee Smart Energy products, but you know, there are a good number of them. And in fact, we see even in places like Korea that companies are trialing Zigbee Smart Energy 1.x. So that's a fairly significant milestone.
Oh, very good, very good. You know, I think I need to sort of qualify something here. I hear this often when people talk about smart grid or what they mean when we define the term smart grid. Let me give you my definition of smart grid. I'm not saying it's the definition. Here's how I define smart grid. Everything from the home area network all the way to generation. To me, that is smart grid. Smart grid is a huge global encompassing term to me. And a lot of people divide it off into, you know, is ICS smart grid, is AMI smart grid. So when I say smart grid, I mean everything. That to me is what I'm defining as smart grid. And again, you know, I've had plenty of philosophical discussions about this term, so I'll just give you what I feel. So, great. Chris?
So, is SafeNet's product deployed in the smart grid? Absolutely. I mean, we're deployed through Landis and Gear, where they're using our products to secure the head-end system in terms of signing messages and encrypting and decrypting messages. So from that, we're also deployed from a message security perspective in the financial industry, where if you look at, we're deployed worldwide with over 5,000 devices that are securing literally every single interbank transaction at the end of every day as banks settle those funds. So, I mean, the financial industry has very much embraced our products. Secure manufacturing, probably half the devices you use every day are protected from both a secure manufacturing and code signing use case by our devices back at the headquarters of the networking gear companies, some of the PC manufacturers, printer manufacturers, chip manufacturers. So, absolutely.
Great, great. Thank you very much.
Yeah, Chris. Yeah. Yes, in addition to having deployed for the Department of Homeland Security, where we got started, we work with defense. We also have recently implemented an access control system based on RFID, where we secure the identity of the cardholders. One of the things that sets us apart is anonymity, meaning that when you have an RFID tag or any microchip for that matter, our algorithm is built in a way that you can't actually trace it. So think about a toll tag where you every time you read the toll tag, it shows a new ID. Could that be interesting for the smart grid? Yes, potentially, of course, if you have somebody pinging a specific house like the White House or any other installation that's of interest. And we also are working, of course, with microchip manufacturers, as you will know. Implementing on microchips a lot of times is more efficient than putting just software on the chip. So actually designing the chip and putting the design onto the gates of the chip is very efficient. So we are working with microchip manufacturers so that they then can take their products into the market. And one collaboration that I can talk about is with Ramtron, which provides the FRAM technology, which is a very, very interesting chip because its read and write speeds are exactly the same. So it's a very efficient chip, and TI uses it, Fujitsu uses it, and Ramtron uses it.
Great, good to hear. So I know sometimes with, one of the things that's actually, and NIST people can attest to this, is when you have something new, it's often a very long, time-consuming process to get the adoption, and I know you're really working hard to sort of, get to that level where people will look at your things and say, okay, this is, this is something we can, move forward with. But I always tell people, everything started, ECC was new at one time, right, Jim?
It was.
So, everything starts, somewhere and, has to, work their way through the process. So it's always good to have innovation, and a good group of people looking at everything and tearing it apart, right?
Yeah, and in that sense, we're a very atypical startup in that we actually sell something.
Right. Right. Well, great, great. So, I guess, and again, so to the extent that you feel comfortable talking about it, but I think it's sort of reasonable to bring this up. Have any of you, or I should say, what have you learned since the inception of your solutions that has caused you to potentially reconfigure the solution to either make improvements or add something that was maybe previously overlooked or simply missing? In other words, did you learn some lessons and say, we got to change things around, and what are they? And I think it's important to point that out because, again, nothing is ever perfect, and security is dynamic, and things change. And what have you learned along the process that has caused you to sort of like reconfigure things and say, we got to make these changes based on about what's going on and what's in the ecosystem today. So.
All right. Definitely at Alert Enterprise, the customer feedback loop and the partnership feedback loop is critical to the product success. We have tremendous partnerships with really successful firms like SAIC, working with ICF right now, trying to develop partnerships, companies like Inkari, working with those companies and getting feedback from what they've seen out in the field. Right, and then talking with our customers and understanding what their needs are has really helped us to reconfigure the product and develop actually new solutions and modules. I can think of one specific example as part of what our solution can do because it provides such a nice graphical user interface and it's a great end user experience. It's very appealing to people that are in security compliance that maybe aren't so technical, but they want more out of it. They want more reporting features. They want more auditing functions, more assessments of their security posture that they can see and interpret. And that's really driven us to create more user-friendly reports that pull information from intrusion detection systems, intrusion prevention systems that are already installed in the system, bring those readings and those logs up to a higher level and allow someone to interpret them that may not be so technical. And that customer feedback loop of wanting to know what the technical data is, wanting to have that level of granularity in their situational awareness has caused us to change our product and provide that granularity at a much higher level. Customer feedback's been tremendous in helping us to develop new modules such as things that relate to asset inventory, and not just asset inventory, but attributes associated with asset inventories. And we're currently working on those modules to add to the service line on the product. So. Customer feedback's tremendously important, and we always want to hear comments. We take away something, I think, from every single demo that we do. Oh, can you do this? Can you add this in? Would we be able to add this into the scope of installation? Yes, absolutely. We want to provide what the customer wants. So,
thank you very much. Jim?
Okay. In terms of, I guess, our AMI product, what we've really done in recent days is look at scalability. So we were initially deploying and targeting very large utilities, and now we're actually adjusting our solution to make it something that can target smaller utilities. And I think that's realizing that the very big utilities, again, drive the thought, they're the thought leaders in security, and they drive the requirements. And over time, you see the smaller utilities, mid-sized utilities say, we need that, we need something like that, we don't need to scale to 5 million endpoints, but we want a solution that we can afford. So that's something that we've worked hard on, is to try and scale our solution to make it affordable for the smaller utilities. And again, we've taken a lot of feedback from the big utilities from Itron around adjusting or managing that, making design changes to make the product more usable for the less IT savvy folks. Addressing also a bunch of, the fact that we're using Linux in the platform, making sure that we can update the core platform on a regular basis and just manage that process. So there are things that we've learned there in terms of deploying an enterprise-ready appliance, again, using a good security methodology. On the Zigbee side, I think the interesting thing, but my takeaway there, that you can talk about interoperability all day long, but unless you have an enforcement mechanism, which is what we actually do have because we run the CA, you're probably not going to get interoperable very quick. So the bake-offs, that's great. You'll get the good guys that are in there working hard to come up with interoperable solutions, but unless you can enforce the fringes, you're probably not going to drive widespread interoperability amongst all the second tier and third tier players that come to the market. So an enforcement mechanism really can help drive interoperability. I think, again, we've demonstrated that with the Zigbee 1 deployments.
Thank you, Jim. You know, I think you raised a very interesting point. In discussions I've had with some organizations that have had to deploy a lot of AMI endpoints, for example, right? In some situations, they run into a situation of not being aware of some of the challenges that come with scaling up, right? But interestingly enough, it's just as important to understand that the challenge sometimes is scaling down. How does a really small organization or a really small utility deal with an issue like key management, or when they don't even have the resources in place to deal with something that was really designed for larger enterprises? And it's always it's funny, there's issues on both ends of the spectrum, and it's great to hear that you guys have approached that and come up with some ways to deal with it. Right.
So historically, our products have focused on algorithms like AES and RSA, but with the introduction of Suite B several years ago, we saw that the elliptic curve was going to become more mainstream, and we went about and invested in some silicon-level acceleration of ECC algorithms, and that has actually proved, this industry has proved that was a great choice, and has put us in a pretty good position to provide that hardware acceleration. But we've also noticed along the way that we didn't get it all right. We focused on Suite B specifically, and we're finding things like integrated encryption schemes are key to this industry, and we learned that through a partnership with Landis & Gyr last year, and we've been, flushing out that algorithm, those mechanisms to support that. So we're going to continue to look to broaden our support in that kind of cryptography, Suite B and ECC in general. From a reliability and availability and scalability, our products have always done very, very well in those aspects, but we've been continuing to enhance those to the point where we can do thousands, if not tens of thousands of transactions per second at a head-end system. We have infrastructure to allow you, if a device does fail, to install another one completely transparently without any interruption of service. So things like that.
So interesting thing about your partnership with Landis & Gyr, I think you've done a lot of work in the financial sector, and oftentimes I hear this comparison being made, and I know some things are valid, but for example, one thing that was probably an interesting challenge for you is, with banks and with financial, devices, their IT-based system, something goes wrong, you change the firmware, you update it, you replace the system, and of course with, when you're talking about things like AMI, it's out there, you want it to be out there at least 10, 15 years, and has that been a sort of an interesting new challenge for you to just, determine, it's like, how does that potentially change the way you view this, a way of doing things out there today?
Well, actually, the financials, at least when they talk about things like hardware security modules, are in a very similar state. They really do not like to touch a system once it's been deployed. So when it's deployed, they like to leave it there for many, many years. They will, if there's ever something that's a vulnerability, they will patch that. But typically, a system will stay in place for 5 years, and then there's an upgrade process where you can upgrade the firmware in the product to make it more current when they're about to change their higher level systems. So I think we're already in a pretty good position there. The products also allow you to do things like do that firmware upgrade by creating a cluster of units. You take one unit out, upgrade it offline, and systematically go through the cluster in a way that service is never interrupted while you're doing that. So,
Great. Thank you very much.
Yes, we certainly are working on a lot of different improvements and at all times. One of the things we see is performance. Performance levels have to be there, not just in the smart grid, but also in industrial control environments, obviously, where you have maybe a 400 millisecond response time of a device. Keeping that as close to 400 milliseconds once we put a cipher on is our goal. So we are already very small. To give you one example, we compared ourselves on an MSP chip to AES and found in terms of battery life, for example, that a 10-year battery life would be reduced to 9.6 years with a Hummingbird cipher and to about 3.4 years with AES. So it's a substantial power saving. In terms of the speed, we're at roughly 2,000 clocks on a typical microprocessor. We're working on reducing that. So basically, the three components, speed and memory and power, we're working on improving all three, both within our existing ciphers, but also with new ciphers, where we're constantly looking at more efficient ways, specifically also using traditional cryptography, AES and such, to improve on that and to create low-weight ciphers. The second area that we really look at very, very hard is key management. Obviously, it's a big problem. Everybody knows it. And when you look at traditional IT networks, key management already is very, very difficult. The internet, right? And if you now take that and instead of having a couple of million certificates or tens of millions of certificates, now potentially you need 15 million certificates for a traditional or typical utility in a week because they have ephemeral keys, because they change. Maybe especially if I use symmetric key cryptography, I need to change the keys regularly, maybe every 15 minutes. That becomes an administrative and management problem of definitely new proportions. And so we're working a lot on building key management architectures and systems that actually allow you to do that. One of the things we've just filed a patent for is a multi-domain key management system where actually several different entities, legal entities, can manage keys jointly based on our cipher, which actually allows them to not exchange keys when they authenticate keys, so the keys actually never send over the network. It's capabilities like that we feel are very important, and everything that we do is based on enabling small resource-constrained device security.
I would definitely say the key management issue is something that comes up often in discussions in the NIST group and in the OpenSG groups these days, and it's a hot topic going on for many months now, right? Right, Annabelle? So it's definitely a good area to be focusing on.